All right, hello everyone. Welcome back. Do we have any new faces today, or is everyone returning from battle boats?
New.
Hi, welcome. I'm Jason. This is Peter. I would like to begin first off by saying thank you guys all for competing in battle boats. I know a couple of you are still wrapping up tomorrow, but it was a lot of fun to watch everyone get their hands dirty in a boat design. I hope you guys had a good experience. I would like to, before we start the presentation today, we have some new leadership members, and I would like to introduce first. I'd like to introduce Michael.
I want to just introduce the entire leadership team again.
Yes.
If we could have everyone who's working controls, including Corey, stand up. Yeah. And including Michael, since you're doing software. Yeah. But also focusing on controls.
Current controls or who wants to do controls?
Current controls, you guys. Yeah, could you two introduce yourselves, and then Michael, introduce yourself again in your position.
Hello, I'm Alex. I'm a fifth year Mechie and Aerospace Engineer, and I'm the controls lead for this year. So I'm very happy to see you guys, and hopefully some of you join.
My name is Corey. I'm a PhD student in mechanical engineering here. I don't have an official leadership role, but I follow you guys around and tell you what to do.
Corey is officially a mentor. So that he's a part of the leadership meetings, but he doesn't have any of the leadership administrative permissions. But he has no power.
I wield unchecked power with no actual responsibility.
Yes, exactly.
Okay.
I'm Michael. I'm a second year electrical engineer. I'm one of the new software division leads. I'm excited to work with you guys.
Thanks, guys. Can I pull up our other software leads, those in vision and systems architecture? Please stand up. Well, your software, stand up. Where's Luna? Where's Joe? All right. So we have our newest member is Danny. Give it up for Danny.
You want to introduce yourself?
Hi, I'm Danny. I'm a sophomore in CS. I joined RoboSub last year, and then learned a bunch of stuff. So now I'm lead apparently. So.
Software division lead.
Yeah.
Danny also does SSS if you're involved with space and satellites.
I'm Joe. I'm a fifth year CS. We're first year master student. Here for also a mentor role. I'm specific interested in vision and software.
I'm Luna, fourth year engineering, and I'm division lead this year.
And then our other division lead is London. You also have William.
He's in London?
Yeah, right now.
He's in London. Yeah.
Yeah.
Okay. Cool. Let's have. I'm gonna have the electrical sub team and whole step up.
All right.
Lucy, you can start, and then we'll go that way. Yeah.
No new members here. But
Y'all are wearing the green. Kind of matters.
Hi guys, I'm Lucy. I'm a second year mechanical engineering student, and I'm the hull subteam lead.
Hello, I'm Dilraj. I'm a fifth year electrical engineering student, and I'm one of the electrical leads.
Hi, I'm Jenny. I'm a fourth year electrical engineering major, and I'm one of the other electrical leads.
I'm Nidhi. I'm a fourth year electrical engineering major, and I'm the third electrical engineer.
Thanks, guys. And then I have.
we just do the last two together.
Yeah. Okay, Kakoa, Alan, and David. Yes, that's excellent. You want to introduce yourselves? Sure, Kakoa, you can start.
My name is Kakoa. I'm a second year electrical engineering major, and I'm the business lead.
I'm David. I'm a second year mechanical engineering major, and then I'm the lead for the manipulation section.
I'm Alan, second year mechanical engineering student, and I'm the mechanical lead.
Okay. Thank you guys.
Thank you.
All right. Hopefully this is the last sort of presentation style meeting we have for a while. But if you just bear with us, shoot, I stopped the recording. Rips. Where did it go?
We can take over. But yeah, today kind of serves as our last presentation style meeting. This is kind of your final We're going to go into a little bit more depth on the sub-teams, give you guys a chance to explore and talk to some of the leads. And starting today, you'll be meeting with your sub-teams, and we're going to start divvying up tasks and responsibilities and start that planning process. So this is meant to like give you all the information so you can make informed decisions about where you want to get involved, and then start getting involved starting today.
Yes. Just as like we're gonna go through some of the slides from the info session, but just to go through that really quickly, like as a reminder, like what we're trying to provide to you guys, this is part of our goals, is to be a bridge between the real world and the classroom, right? We want you to be building skills here that you're able to talk about with potential employers and other people, that makes it feel like that you're learning and that you're able to leave this program and also UC Davis better than you started. As part of that process, there's a lot that you can do, and we'll talk about that later. But just to revisit that, that's where we're coming from.
I'm gonna power through this really.
Yeah, we're gonna.
Some of this is reused from the orientation slideshow, so I'm gonna go through it really quickly, and then we're gonna focus more time on the stuff that's actually new. So if you're new here, we're an engineering competition team. We compete in an autonomous underwater robotics competition. This is our third year as a team, second year competing. We're trying to be like the go-to place for serious robotics here at Davis. And then we're also trying to be like a safe place to socialize. We're doing a social later tonight, and we'll talk about that in a bit. Let's move on.
This is the wrong presentation.
Yes, you are using it.
That is why it's not. I was like, their slides are wrong. There we go. That's the one I was expecting. Okay. Apologies. Okay. There we go. That's why I was okay. This was the slide we were looking for.
Okay. Okay, I can do this. So we compete in the RoboSub competition. I want to note really quick, we're going to be doing a Kahoot at the end of all of these presentations. So I'd encourage you to like pay attention. It's not that serious, but just to like help reiterate some of those key points. I'm saying that because I think there might be some questions about this. First off, it's an international competition. About 60 teams compete. It's an autonomous underwater challenge, so the robot is dropped into the pool, and then we get 15 minutes for the robot to autonomously navigate, completing a series of tasks. And for the competition, what we submit is a technical design report, our team website, a team intro video, and then we also like do a presentation when we get there and just bring our robot. So those are the things that go into kind of ranking how we compete, and that factors into our overall placement at the competition. And then it's this summer, it's happening in July this year, second week. Move on.
It's 1 week long. So as a reminder, this is where we left off at competition. It went underwater, we qualified, it was great. Oh my god,
Yeah.
I'm so happy.
I just want to say, so this is the qualification run. This is a practice for the qualification run. In order to get to the semifinals in the RoboSub competition, all the robot has to do is submerge and drive through that gate. So it's like a PVC archway. That's all you have to do. The actual competition's a lot tougher than that, but getting to semifinals, just get through the gate. And surprisingly, it's really hard. I think there was like maybe 15 teams that showed up at the competition and couldn't get a robot to drive underwater and through the gate.
Yeah. So just like building off of what Peter said, we placed pretty well. Like we're very happy with our placement as a first year team, but there's a lot of room for improvement. I do not want anyone to have the impression that we are anywhere near done. There's a lot of work to be done. Not to mention we are also going to start building a new robot. So there's plenty to do. Some of the things like I just mentioned here, unfinished controller, corrosion, insufficient testing, kill switch, those are like a small list of the total things that we are still to do. So like we're really excited to come in this year and get started.
Yeah, and for that, I think our goal this year, because we're trying to be pretty ambitious, is we want to be in the top 10 overall at the competition.
Yeah.
And I think that is actually a realistic goal for our team.
Yeah.
But it's going to take a lot of work to get there.
Yeah. That's our robot right now. It's on the table. Manatee. This is the one we're gonna be building off of. Manny's mostly mechanically done, so we're probably not gonna be adding any crazy new stuff to Manny outside of some manipulator things and maybe some research stuff. Electrically, we're going to be doing some stuff with PCBs. I'll let the division leaders talk more about that later. And then this will be the main vessel for all the software testing happening this year. So feel free to get familiar with Manny, and then and people interested in mechanical stuff, your project will be mostly focused on the new vehicle. I don't know what that says. Okay, so software controls. This is what we did last year.
Wait.
No?
Aren't the division leads?
No, this is.
Yeah, this is their slides.
Oh, this is your slide?
This is whoever made
Yeah,
the slide.
they're presenting their slides.
Okay, so I'll let them talk about it. There's a slide in here that okay, this got misordered. I apologize. Okay,
I did change some stuff, so you exit out it and you come back and
this is not your slide, bro.
I did not put that cross there.
I put that cross there. That's why it was nice. Okay, all right. This is old news. We're building this like not from scratch. We have a lot of stuff we're using from last year, but we need to redo this. This is I'll let them talk more about how we're gonna redo it, but this is being changed.
Yeah.
This is like high level stuff. I'm gonna move on. Here's the timeline. We just finished battle boats, so we're doing right now mechanical design for the AUV for the new one. And we're doing a manual electrical rework, and then we're jumping headfirst into software development with the old guy. I'm gonna really quickly remind everyone of how we're structured, and I'm gonna let the sub teams take over so you guys can learn more about the sub teams and where you guys can get involved. We have whole manipulation, controls, systems, architecture, vision, research, and business. You can see the divisions are not necessarily groups you're a part of, but they're the skills that you wish to hone. So you can see how each of the sub-teams is very interdisciplinary. And what we encourage you to do is to join as many or as little sub-teams and divisions as you see fit. Typically we see people who are in 2 or 1 to 2 sub-teams be the most successful. If you're doing 3, you either have a lot of time on your plate or you just crack that in your mind. You can do more than that, but it does become a pretty split time investment. Consider what it is you want to focus on, and you're welcome to attend meetings to just get a feel for what everyone's doing and see what meeting times work well for you. But generally speaking, we're very flexible. There's work for everyone in every division, basically. So everything's around. I think this is whole now. Okay.
And I really quickly wanted to give a preview of what's happening today. So we're gonna do this presentation. The sub-team leads are all gonna present. Then we're gonna do a little meet the sub-teams thing, where each of the sub-teams are going to have a table and you can go over and go learn about more in depth about what their goals are for this coming year and what they do. After that, then we'll be splitting into groups, and you guys will actually go to whatever sub-team you would like to start working with today. And they'll start talking about the priorities and splitting up tasks and giving you guys an intro into what you need to do. And there will be a Kahoot after this presentation.
Okay. All right, with that, I'm going to pass it off to Lucy for a little bit of poll.
Okay, hi guys. I'm Lucy, the Hull Sub-Team Lead. My job is to improve and maintain the physical robot. So that's all of the mechanics and electronics that you see. Firstly, you have those electronics. Our goal is integration mainly. We're trying to build up the whole system, taking in the different sub-teams and being able to actually make it work with all of those different electrical components. Some of the things we work on and skills we build are with CAD, 3D printing, wire routing, soldering, designing PCBs, and more. Beyond that, we also have the mechanical side. The mechanical side is mainly working on designing and fabricating mounts, brackets, and any kind of guards. So it's a lot of user safety, ergonomics, and things like that. Beyond that, like I said, we have a lot of different skills we work on. We work with CAD, 3D printing, metal machining, assembly, and much more. But Hull is mainly interdisciplinary. You may join saying, I'm going to only do CAD for mechanical, and you're probably gonna end up doing a lot of CAD for electrical stuff, like designing board mounting or anything like that. And then you can see our first meeting is next week. Beyond that, we also have a bunch of upcoming projects. This is a very short list of what we have upcoming. So for example, we have a battery management system, reworking the entire insides of the tubes, heat dissipation, LED signal lights, and designing and manufacturing a new camera box. In general, we build the foundations that every other sub-team adds on to. So having a strong and robust foundation in how we design and build things means that other sub-teams can do amazing and skyrocket our robot to the next level. And then, like I said, our next meeting is next week, so if you're interested, come talk to me. We'll figure out our time for our meeting and get you guys started. Thank you very much. Yeah. So jumping back actually to the new robot design, there has been almost nothing so far. So that means we have so much opportunity to figure out what we want to design. That means it's an electrical rehaul, it's figuring out the mechanics. And beyond that, we've tossed around a couple different ideas. You can see here that our current design is a tube shape. We're playing with a box shape, welded sheet metal, I believe, is what we're going with so far. And then figuring out all kinds of new information. So if you're really interested in like electronics or mechanics, this is a great opportunity to actually start from the ground up and figure out what's going to work from that foundational level. Anything else? Okay, thank you guys. I will pass it off to Alex, controls, Danny.
Thank you, Lucy.
Testing. Okay. I don't know what happened to the order, but anyway, okay. So as we said before, the old diagram is actually not that accurate. There's some components missing, and we end up not doing doing certain things like the way we wanted it to according to the diagram. This is us locked into a room, and then we draw like the actual like what we have right now, sort of. The names of the components are like a bit different than what we have currently, but like we plan to have like we originally have like a dashboard for like displaying data and stuff, and then this year we're trying to do remote control on the robot because it used to be just fully autonomous, and so that's part of the joystick component. Where exactly things go in this diagram is a little bit up for debate, but like at least these are the software parts that we'll have for like the robot sort of. And so if you want to do like remote control of a robot this year, that's something we're doing. Not on this software stack as like, simulation or like any other things that like helps us test our architecture, mainly because like, we actually need to pull up to a pool to test the robot because it's a submarine, and usually you get like that once a month, maybe less than that. And then we also work with controls. So like, for example, you can see we have the, my class is a little bit bad, but if you see a thrust controller, that middle part is all like, control stuff, and then we work with them to like, determine what way the robot is heading and stuff like that, converting user commands into actual motor control stuff. And then we also work with vision, and then like, they feed their data into like the ID controller. Vision is still like working on their stuff right now, it's still getting finalized, which is why it's less detailed, but yeah. And then we also have like, we work on the Raspberry Pi, and we work on the Raspberry Pi Pico. The Pico is for motor control, and then most of our code either goes on the user's computer, like the actual PC, or like, it goes on Raspberry Pi. Yeah.
Extension.
Rocks. Oh, I was trying to leave it out, so I can do
Okay.
Yeah.
Focus on the goals. Yeah, what are people going to be working with there?
So this year in software, we planning to work on simulation because mainly access to robot is like, it's a bit annoying because you can only run one thing at a time. So ideally you have some simulation stuff that will help. And then it was a bit of a mess because during competition, we sort of brought out everything in like 1 week. So like, it would be kind of nice if we sort of clean up a little bit. Like a lot of the stuff we're still going to reuse because there's value in that. It does what we want. It's just like, in terms of like clarity or like, like cost of concern, like what part of the code is doing what, stuff like that. And then
I'm not showing this diagram is actually research. This is something that we always wanted to do. You know, back in we actually gotten approached by one research center in Davis, and they wanted to do research in Tahoe, but we weren't prepared for that. So this year we wanted to be. And then electrical might design some new boards such as the battery management system. We want to be able to integrate that in our system as well.
Yeah, that's fair. But yeah, so Dan, this is like the software architecture sub-team.
That's next slide.
Oh, that's the next slide? Okay, I think you should, get through it, because we have a lot of people.
Just press the right arrow. The right arrow.
Oh, here are the manipulations.
Okay. Yeah, the slide order is a bit messed up right now, but yeah, I'll just give a really quick surface level overview of what manipulation is going to do. If you want to find out more, I'm going to be going more in depth once we split into our individual subteams. So manipulation, we handle all the manipulators on the robot. So those are what manipulate different objects in the environment that the robot is in. So for example, here you can see the first manipulator that the competition has. There's 3 different manipulators, and it's the gripper. It's pretty self-explanatory. The competition will have different objects scattered around the field, and then we need to pick them up and then move them into a bin. And we need to design a gripper that can do that all autonomously and very reliably. And that's where we go into the main thing that we're going to work on at the start of this year, which is we want to design a new gripper from scratch. Because last year we designed one, you can see it right here, but it didn't really work well enough to really be implemented into our robot. So we're hoping to design one with a completely new mechanism and a completely new control scheme that would hopefully pick up different objects. So, why is the arrow not working? Yeah, so we're gonna be out with that one. And then talking about the other manipulators that we have in this robot, we also have a torpedo. So the torpedo is, we design our own launcher and then also our own torpedo. It's going to be about maybe 4 to 6 inches long for a sense of scale. And then that's gonna be shooting through different holes that the competition marks as targets. And we're gonna be overhauling it. I'd say that our design currently is on the final stretch. It's just that it kind of has a problem where since we 3D printed the entire barrel and it uses lots of energy to launch the torpedo, it kinda just explodes every now and then, which isn't the best. So we're gonna be playing around with different manufacturing methods and just a general design alteration to make the barrel a bit stronger and to get that design fully finished. And that sort of leads into the next thing that we're hoping to do as a team, which is transition towards more machines parts, because currently I feel like we have a kind of over-reliance on 3D printed parts, which are great. They're amazing for rapid prototyping, but they're kind of weak, and compared to machined metal, there's just a huge gap in terms of strength and durability. So if you're interested in learning how to machine in the machine shop, or just general design for manufacture, this would be a good sub-team to join. And you can also see here, it's kind of our third manipulator, which is the dropper. It drops markers onto the course, just onto the ground, and then it marks different objects. And yeah, we're gonna be hopefully turning that 3D printed mechanism into metal. And finally, we're just gonna be collaborating with research and other sub-teams throughout the year. If they need any small mounts to be made for sensors or just small general tasks, we tend to help around because compared to the other sub-teams, we have a much wider kind of breadth of what we tend to do, just due to not having a huge project to work on at one time. And if you want to find out more, we're gonna be having our first sub-team meeting this coming Monday. It's gonna be in the ESDC. I'm gonna send an announcement with an official location and time, hopefully later today or early tomorrow. So yeah, hope to see you guys there if you're interested.
Hey guys, so as you heard before, my name is Kakoa and I'm the business lead. My counterpart Aubrey is the PR lead. Unfortunately, she couldn't be here today. She has a rowing competition, but she's awesome to work with and we'll work very closely together for the year. So some of the kind of stuff that we do mainly has to do with recruiting club members. So I don't know how any of you guys heard about the club, but hopefully it was due to a good PR effort and not a negative PR effort on our part, just to get you guys into the door here today. Another thing we do, because we do need money, the robot is expensive, I don't know if you can tell by looking at it, is we provide updates for our sponsors. And so we tell them like, hey, this is how we're using your equipment, this is how we're using your money. These can be like corporation sponsors, but also we love our families or parents who give donations as well. So we try to let them know that we're not just splurging on anything unnecessary. And then lastly, we do the social media. So this can be posting updates and also the occasional spicy meme. Now, whether you find that meme wonderful and you want to make more yourself, or you think it's incredibly cringe, in which case, feel free to outdo me and join PR, and you can make some of your own. Now, for the future year, we're hoping to reach out to more sponsors. Again, stuff is expensive, as well as organize some crowdfunding fundraisers. We can get more into that if you come over to the sub-team meeting. And then lastly, we do have a video that we need to submit to the competition every year. So here you can see the thumbnail for our video last year that was Shark Tank themed. So we'll be working on coming up with a theme, filming, editing, doing all that stuff. Is some great skills to have, I think, that you can apply to everything. So if you're interested in any of that, then I would highly encourage you to come check out PR, especially because we are not exclusive. So feel free to join any other part of the sub-team. We're not on all the time, but we'd love to have you. Some great, skills to have overall. Thank you.
Hello, my name is Hannah. I'm not a lead, and the lead couldn't be here. Her name is Aditi, and she's really sweet, but I'm just going to be speaking, I guess, on behalf of her from the research team. So, yeah, wait, why isn't the button working?
I did that to David too. Oh, that's not
No,
the button.
that's not the-
You're hitting the left click.
So sorry. I thought it was just like, also just
This one.
there.
Yep.
Thank you. Okay, so on the research team, our goal from last year and going into this year has been doing an arboretum deployment to essentially do a water quality analysis on the waterway after construction. So it would serve as some data and deliverables that would help them understand how the reconstruction of the arboretum actually helped out the aquatic environment. And then maybe sometime in the summertime, when we successfully do an arboretum deployment, we will reapproach the statuist lab that we got in contact with last year and try to do some ocean science application with the Coastal and Marine Sciences Institute over in Bodega Bay. So doing more water quality analysis, but also maybe some sediment sampling was in the talks. And then so our overarching goal would be super, super great if we could, and we plan to, approach Tahoe Environmental Research Center. And they do a ton of really exciting science with water quality and just general limnology, physical and biochemical. And so we would like to be able to take Manny out there is our goal, since Manny is pretty much built mechanically and electrically, and see what it can do for the Tahoe. And then, oh yeah, our meetings will take place during the general meetings on Wednesday, just 6 to 7 p.m. And then
Sorry, general meetings are on Thursday.
Oh, really?
I think she said Thursday.
Okay, so sorry.
That's okay. Yeah, it's just a Thursday.
Okay. All right. Yeah. Okay. And then yeah. So what will in the short term, other than grant writing, because that's another area that the research team does contribute to, we are going to be designing a separate mount for the scientific sensor payload on the robot. so we don't have to integrate it with the current electrical system, because we had some problems with the sensors last year when we did try to integrate it. So that will include CAD, software, and electrical, and a lot of teamwork with the other teams like manipulation and electrical to help us out with that. And so if any of that seems interesting to you, I would love to see new faces on the research team, and obviously, like everyone else said, join as many or as little teams as you like.
Who's it gonna be? Ooh.
Okay, so this video playing on the PPT is the current state of the vision system we have. And you can see there's a lot of room for improvements. Out of the entire frame, we're only extracting the two shark images hanging on the gates. And we're not doing where the gate is. We're doing any 3D reconstruction of the scene we see. But yeah, that's our current working system, and we do plan on keep improving that. But with more people and more manpower, we could move on to what we have tentative tasks, which here are all big and some may overreaching goals, but we hope to get that started with your help. And meetings are to be decided when you come to talk to us, and we can decide the time in regular weeks we can meet. Okay, that will be all. Join Vision, it's super cool. Hello. Oh, you. Oh. Oh no. I did it too. Oops. Oh, there you go. Okay, this one. Nice. Hi, everyone. I'm Alex. I am your controls lead this year. Woo! Our biggest question is, can we do everything the other team does, all the other sub-teams, in MATLAB? That's pretty much it. That's a joke. So the big two things that we do is controls and simulation. Now controls, very simply, is just developing algorithms to help us move the robot in the way that we want it to. And simulation is developing the physics model, the environment, the pool, all of that. If that interests you, please go over to Corey and I on that table there, and we'll talk more about it in depth. They are hand in hand. You can't do controls without simulation. This is typically how it's done in industry, although during our, let's see if this works. Oh, there we go. During our competition, we did a lot of testing to actually tune our PID controller manually. So there it is running. You can see it moving with waypoints, and that was really fun. It took 2 all-nighters. Hopefully we won't have to do that again. Hopefully we'll have to spend, and that's another one of Corey watching it spin. Hopefully we will just need to spend 3 hours Tuesday, Friday, every week until competition, not 2 all-nighters. Yeah. Just a heads up, it's not a 3-hour work session that you have to be there for. I'm gonna be there for those 3 hours, but you are more than welcome to be there. Just drop in and work with me. That's pretty much how me and Corey kind of wanted to go. Just again, you are not required to be there for all 3 hours. Ooh. All right, now for upcoming tasks, we have a lot of things that we want to do. These are just the things that we can actually most likely do this year. So hardware in the loop, that's where we have our computer hooked up to Manatee and testing our MATLAB scripts, testing our controllers, testing our simulation.
that's hardware in the loop testing. But if you want to learn more, please come talk to Corey and I. We want to improve the physics model. Right now, we have really bad hydrodynamics. We need to improve that. We want to create and improve an environment. So that's the simulation I was just talking about. Implement camera and sensor models. We have a camera and sensor model preliminary. It's not really fully developed. We want to do a lot more of that. And finally, improve the controller. But we're pretty sure that we can do that later on. That's not too important, interestingly. All right, thank you.
Is this you again?
I told you this like
Okay, yeah, you should come up, and we'll go through it, and just like keep it concise.
Okay, here's the actual system architecture slide, which I was expecting. But yeah, so our system architecture lead, William, is currently in London, so I'll be doing the talking for him. But so what is system architecture? So it's actually the software team and the design team for the software side. So it's kind of the glue, quote unquote, managing, like connecting all the robot software together and like connecting to the hardware and stuff. So one thing that we did, for example, during competition is, we have a mission file of like all the stuff that a robot's gonna do. Like it has waypoints, it has like, the tasks that you can do, for example, recognizing the objects and like, picking something up, stuff like that, And then we parse that file and we turn that into a sequence of commands that a robot can run. And then we kind of do integration with vision and then other sensors besides like, our current ones, like, we have accelerometer, stuff like that. But since we're planning to do research, we would need to work more on that. And then, and then we also controls like the cluster control, stuff like that. That's all part of system architecture. The name is a bit misleading, but anyway. Most of the code base, so we primarily use Linux. If you have Windows, I'm sorry, that's not a real operating system. But most of our code base does target Ubuntu. But so we probably have you install that. But anyway, that's besides the point. Go for this year is we want to rewrite last season's code. I already talked about that. And then this says C++ here, but like really it's kind of free. You can do Python, C++. Probably just those two, but like whatever you sort of want. But yeah, we won't restrict you to like using, you have to use this or you have to use that or like whatever. We will give you a couple of options that you sort of choose. Because most of the stuff we have a way to make it interoperable. So we can sort of lean on to what you would like to use, basically. And yeah, the meetings is supposed to be this week. We'll send it out, but yeah, stay put your ears out for that, I guess. Yeah, okay. Yeah, the slide's out. Okay, cool. All right.
Okay. Thank you guys for listening. Before we break out and we talk, I just want to like remind everyone like sort of like what the team expectations are so that we're all on the same page. So again, independent learning. Your sub-team leaders are going to provide you with lots and lots of opportunities to do really cool things. And they're going to have a lot of insightful knowledge and know-how and command of the subjects that they are in charge of. That's why they're leaders in their respective domains. They also are students and have limited time and cannot sit down with you every meeting to walk you through every single thing. We need you as team members to take some amount of self-initiative and to actually go out and learn the things that you don't understand with us, right? I'm not saying, hey, here's a Gogurt, go find out how to do the entirety of visions, okay? We're here to support you, and we want to help have that conversation where you guys know what questions to be asking, and that way we can go find the answers together. So, please, can I get you guys to promise me that if you guys are lost, that you would come and talk to us, but that we're here together to learn together. Cool? Okay, thank you. What's up?
We have the
Okay. Also, did skip the electrical slide? Was that?
That was on purpose.
That was on purpose. Okay.
We have
Okay. Time commitment. So we have 2 general meetings per week. One today, one on Thursday. Generally, the way that everything works, the general meetings work, is that the Saturday meeting is gonna be the one where we do like bigger team updates. The Thursday one is more of a general work session. With all meetings, the policy is if you can make it, great. If you can't, that's okay. Please check in afterwards on the Notion or on the Discord to follow up and see what you may have missed. If you have homework due, you're encouraged to actually come and join us regardless and just do homework there. Like you're welcome to be doing stuff that's not RoboSub related. If it's a 1 hour sub team meeting, you should that's probably gonna be more focused than like the Alex 3 hours control meeting where that's more of like a general work session. So talk to your sub team leaders, see what works for them. But generally speaking, you should expect at least 4 hours of meetings per week that you can attend. You can attend more, you can attend less. You probably should expect to spend some time outside the club if you actually want to get some value and actually work on some cool stuff, because you can't do necessarily everything in the club. Lastly, please make sure that you are working with other people. When we assign tasks, we try to do it in a pair manner where you and someone else will go work on something together. And the idea is that hopefully, because you have someone else to bounce ideas off of, you're less likely to get stuck and frustrated. It's important that, try to get to know people, but also if you really feel like something's not working, please come talk to us and we can try to figure something out to make that more accessible to you. Lastly, what's not mentioned here, I do want to briefly mention AI. I know it's come up a couple of times. Talk to your sub-team leaders about how they feel about using AI in their specific projects, because it's going to differ based off of what you're doing. Generally saying, the way that you should treat AI, in my opinion, is as a tool, not as a replacement. So in the same way that you're going to use a hammer to hammer a nail into a board, you're going to use AI to help you solve a problem that is difficult to solve by yourself. But you're not going to use a hammer to remodel a toilet, okay? That's not, don't have AI just do everything for you and then just copy and paste the results. That's not learning. And I imagine that's not why you're here. So as you use resources and tools online, please consider what the impact is and whether or not you are getting something out of the process. We're here for you guys, and we want you guys to be successful. Anything else?
Yeah, I think I also just wanted to mention, starting off, it's gonna take a second to get things going and to kind of get our momentum and groove, and for all the sub teams to figure everything out with the new people. I'd encourage you to make sure you stick with it through that first week or two, because especially by the end of this year, if you're still on this project and you've been working on it for the full year and you make it to competition, it's kind of a pretty transformative experience. And that's when things get serious. That's when the most learning happens, is right up at those last couple weeks at the end. But it takes sticking with it the entire time to get that kind of golden experience of seeing everything come together and testing your systems at their full capacity.
Yeah. It is what we're doing is hard, and you're going to feel frustrated, and that's okay. If you manage to push that frustration, you will be rewarded.